I would make is the, in the last 18 months or so, the maturation of the consultants that are helping the utilities has started to actually even out the responses. We used to see big differences in large utilities from small utilities on security, but as consultants that now help the utilities form their RFPs, and as they've matured and their depth has matured, we're seeing a much more even kind of approach to it.
Yeah, and I attribute some of that to probably number 3 on that list of advice, which is go to the NIST CSWG events, go to the OpenSG events. There's a lot of already consolidated knowledge in this industry. Bobby's got a nice piece of work that's been put together for security profiles. It's a great starting point if you're wanting to look at what questions do I ask regarding security for the smart grid. So I think that's helped as well. I think the NISTer publication has helped a lot. In some ways it's hurt. I think we've all seen where somebody's gone through and just cut and paste darn near the whole NISTer and put it in an RFP and, and said, you know, meet this.
I want to echo what you just said. I was just going to say that, you know, there's several NIST meetings a week, and you know, I'm always there. Steve's always there. Most of these, you know, the AMI vendors are there, and anyone in any utility that does not take part in OpenSG is really doing themselves a disservice. You could learn an enormous amount about security just by attending OpenSG meetings on the phone.
So that's maybe a little bit about firmware development. It's a little tricky because I think, I mean, this topic in and of itself, we could spend a week talking about it. Ed could probably do a whole day on static analysis tools, and there's a lot of them, and there's a lot of interesting things you can do there for firmware. There's a lot of interesting things you can do on the head-end systems, which are typically some web UI front end to a database. The next thing I was going to touch on, these are a little out of order, is back to SDLC. So again, at its highest level, what is SDLC? It's about providing assurances that a system was developed in a secure way. And this is not a definitive life cycle. This isn't agile. It's purposely chosen to not be any of those because it works for all of them. But at the end of the day, you're going to build a pile of paper similar to what was built for ISO 9000 that provides some assurances that things were done in a secure way. And this is really, I think over the last year or two, we've all been working to put together our systemic protections, and a lot of vendors have come a long way, and you're seeing a lot of maturity as far as systemic protections and mitigations. This is really where we're going next in terms of AMI security, is providing the auditable proofs. Now, we don't have a benchmark, we don't have a common rubric that says, you know, do these 7 mechanisms, and that's what we're looking for. I would make one strong point here, again back to the smart card and the microwave. This is a false positive. If I provide you all of this paperwork, that's good. That means I've done a lot of the right things. It doesn't mean it's a secure system. If I don't do many of these things, that's a bad sign. Now, so again, it's important to ask for. It's important to think about. It's an important conversation I think we as an industry are going to be having over the next year or two as to what that list is going to look like, and how much of that list is going to be testable. And last slide. Picking a penetration tester. So this is something that you'll see a lot, all of us are doing, I believe. Most of us are doing it in-house as well as hiring externals. I think all of us are hiring externals. So we have people in the AMI system providers whose job it is, who has the title of system tester, security system tester, security pen tester. They're attacking the head end, they're attacking the endpoints. And then having a third party come in and help provide a good analysis of what are the vulnerabilities in the system. This slide came from our product management team. It's an interesting discussion point. The tiers are interesting. I think really what's the first one there should be heavily weighted. And trying to determine, okay, I have a pen tester, how good are they at attacking a system? How good are they at attacking firmware? How good are they at attacking embedded systems? Which is usually it is a completely different skill set than attacking a head-end system, this web UI, than attacking the database, than attacking the infrastructure, the scalable server system, the MDM, than attacking the comms infrastructure. These are all different skill sets. A lot of times, you're not going to find these in one shop. You're going to have to go to multiple shops. And so finding this breadth of maturity on attack testing is not trivial. Ask us, ask Ed, ask me, ask Guido. We'll quietly mention some vendors, that at least the list of vendors that are worth talking to. The organizational maturity. So this is really about how does the pen tester deal with information. So they've done this pen test under NDA with you. We're very much like Itron. We have an open policy when it comes to vulnerability disclosure. We share everything with our customers. When the pen test is complete, we take the full report, not an abridged report, not a summary of the report, but the full report, and sit with our customers and go over where the vulnerabilities lie in our system and start, and the important part of that conversation is mitigations. So here are the vulnerabilities. Almost always, well, is another thing to look for in terms of maturity. A good pen tester is going to provide you mitigations. They're going to say, look, the device in question can be attacked, but it happens that the device that we're talking about, you put in a substation. And most attackers, if it says high voltage on that box, aren't going to open it. So a mitigation we'd recommend is putting a sticker on the box that says high voltage. Now, you haven't solved the problem, but you have a mitigation. That works. So, the having a pen tester that is good at thinking really out, these are your, not just a little outside the box, they're way outside the box thinkers. Don't be surprised if while they're at your site, they hack into your corporate LAN, they social network your infrastructure. It's just, it goes with the territory with this type of individual and these types of organizations. And then the last one's industry maturity. Are they new to the power industry? Is this something that they don't know anything about AMI? They're completely green to this field. And it's not a stopper, but it's something also to have, I think, as a metric to understand where do they fit in terms of ranking a pen tester and choosing a penetration tester. So I cut short the firmware discussion, which was getting a lot of talk here, the most non-text, just picture slide. Maybe we'll talk a little bit more about secure firmware. So it's interesting. The SDLC mechanisms, a lot of these things Lannis and Gear and a lot of our competitors were doing before security became as large a priority as it was 4 or 5 years ago. So a lot of the things you'll see on an SDLC checklist are the things you do for quality systems, which quality is been very important for as long as we've been developing these systems. Change control, how you manage change in the system, how you introduce change into the system, whether it's hardware or software. You see that very well managed across the vendor space. Release control, what is released, what's the revisioning, how is it managed? You do see a lot of code audits. I think adding in the security focus to the code audits and having security attack testing as part of the code audits, that's something newer. But again, it's not like we were at ground zero and I'm newer to this industry. I've been in the AMI space for about 2 years. I've seen some growth, but it wasn't like when I came in Landis and Gear was at 0 with security. There was already a well-established program of a lot of these types of mechanisms. So, if you're going to attack one of these systems, maybe talk about another interesting topic here. Actually, I'll ask Kevin, where are you going to go with this system? If you're going to go in this guy, what's your favorite attack point?
Well, being one of the things is the least difficult attack. So where can I get the most traction the easiest with the least amount of work is really what it comes down to. And what my goal is, if I want free power for my house, of course I'm going to go touch your meter. Most of the anti-tamper protection devices and meters are, one, they're usually identifiable from outside the meter, so I know what I have to go after. Small drills, hypodermics, little super glue, and those little balls that roll around in there, they stop. So, it really depends on what I want to do. If I want a cheap bill, I go after my meter. If I want to own your company, I'm going to go after your head end. I'm going to go to that midpoint, one that normally is probably close to my house, so I don't have to travel very far. My exposure to risk to being caught, I know all my neighbors, they know to stay away from me, so, they don't say a whole lot when they see me climbing the pole at night. So, it's my comfort zone. Where can I get the most traction the easiest?
Yeah. So again, it's what you're trying to compromise.
Yeah.
So back to the attack tree from before. So what are we trying to compromise? Where are we attacking this system? If this is a large-scale compromise, really the command and control is the primary attack point. If you want to collect data on the infrastructure, a lot of times this takeout point is more publicly accessible. I don't have to get into the utility to get at the takeout point. But again, a lot of times they're at a substation. Kevin will go into this, I think, a little bit more. But the command and control is less a technical attack and more an attack on a person, whether it's compromising an individual or an individual who already has a reason to be upset with the utility. And that's really kind of the interesting state we're in right now. So we've put a lot of mechanisms in place to defend on the embedded side. We've put a lot of mitigations in place to defend on these people and process sides. And I guess I would end on one thought, which is we put a lot of effort in the payment systems for protecting PINs. So you look all over the payment landscape we're all familiar with. You swipe a credit card, it's a low-end device. The account data has, for a long time, flowed through the entire system unencrypted, was stored unencrypted on a server. Visa, MasterCard. This was not the primary concern as far as an attack point. The primary concern was that PIN. And these very expensive devices are in the ATMs to protect the PIN and the keys that are used to encrypt the PINs at the ATM. But more mechanisms are in place to protect that PIN that are put in place to protect the PC that can dispense the cash out of the ATM. The host systems where the PINs are decrypted, again, a high level of security is put in place for those PINs. And there was a lot of analysis, threat analysis, risk analysis was done in the 70s and 80s where this was the attack vector that was expected. Now, of course, we know they went to the account data. The account data has turned out to be, and it's an attack of convenience. It's hard to get at the PIN data. The cost is very high, and I would say if you talk to a room of people like this one 30 years ago about payment, the idea that the data breach would be what that community would be worrying about today would be laughed at. And that's really probably what keeps me up at night, is that we're missing what's going to be the data breach in 30 years. We're doing the analysis, we're doing the right work, but I think as these systems get deployed, we're going to learn, we're going to have to be a little bit reactive and probably quick to understand where the repeatable low-hanging fruit is for these types of systems.
I think we got time for a couple of questions or whatever. You kind of bring up a good point just on that topic. So historically, we've talked about meters being deployed and put in the field for like 15, 20, 30 years, or whatever like that. And so how does that compare with threats and vulnerability? 10 years from now, some of the things that are hard to get at, like you mentioned, are maybe trivial in the future or something like that. So are we still, is there still an expectation that we're going to buy a meter and it be in the field, or is the firmware mitigation is going to take care of these things and updates and things like that, or what's the...
So the question is, meters are being put in the field for, historically for 30 years, and they were expected to last for 15 to 30 years. And with the evolving nature of threats, what is the expectation from customers and suppliers in terms of how these will be dealt with? And the expectation is, for my customers, is that these devices will be in the field for at least 15 years. I'm not seeing 3 to 5. That'd be great, I guess. But the expectation is 15 years at least. And what you'll see as a result of that is number one, the firmware download capability on these devices becomes very important. And secure firmware download becomes very important for that to be manageable. And then how much space is in the devices. So it's a typical conversation to have with a new and existing customer about how much space is left in the endpoints and upgradability.
The cost or dollar sign, I think, is associated with upgradability to some degree.
No, well, there's obviously a cost associated with it, but I would say it's expected. I think the customers are just expecting that there is a certain amount of availability for upgrade. Now, having said that, there's a variety of vendors. We play to a certain part of the market. I think there's some vendors that don't have as much space in terms of upgradability, and maybe that's where the 3 to 5 year number comes from.
A rule of thumb for headroom for you guys? Is it may not be your area.
No, it is. I'm trying to figure out how to answer that diplomatically. You want to be competitive with the marketplace. So in terms of what you provide as far as headroom is concerned.
Let me restate it for you. Memory costs money, so you have to have enough extra without making your product so expensive that nobody's going to buy it.
Well, there's a funny thing there too, though. So again, this gets back to these interesting push and pulls with developers. There's a point where smaller memory costs more than bigger memory now. So it is kind of a funny, so then what you're dealing with is change costs money. So changing the board, changing something costs money. But by and large, I think most of the footprints are fairly manageable in handling the upgrade path.
Any other questions?
My understanding is that what you described was a complete AMI system from Landis & Gyr, from the meter and the communication up to the MDMS. But Landis & Gyr also is selling the communication, selling the meters with the third-party communication modules.
Sure.
There's Itron and also everyone is doing that. So I'm wondering, do you apply similar tests or requirements to those other vendors, so the complete meter with the communication, with the third-party communication module represent the same level of the security and other SDLC requirements, for example?
Yes, there are SDLC requirements. Yes, there is systemic goals. They're different for the different systems. So the application level security that sits on top of our networking security that's in this Landis & Gyr solution is different than what would be in Itron solution. And in that case, that systemic security, we're a metrology component that plugs in, and that's the, in terms of the systemic security, that's the extent of what we would provide. But we certainly work with this co-opetition line, right? So we definitely cooperate with the radio vendors when it's not our radio and it's their system, their head end. But you do see a lot of mix and matching in some of these systems.
And absolutely, sorry, if you don't mind.
Yes, that's definitely a good question, sir. And that's one of the things that needs to go into the acquisition process, the vendors, making sure that the vendors have talked together. And so it's up to the customers, the utilities that are purchasing these solutions to ensure that they're asking those questions in their RFP process so that the vendors can see that they do need to do that communications as well before they get to you guys.
All right, I got 43 minutes, 25 seconds. I got a minute and 30 seconds. So let me use my minute 30 there. So I was in Texas this weekend, and it was funny. I don't know if any of you saw we were at lunch. We were talking about default passwords and systems with default passwords. And it was about 4 years ago. Somebody had gone all around Texas and hacked into the road signs. The side of the road says, slow down, 25 miles an hour. And they replaced all of them with zombies ahead, beware of zombies, zombies out at night, zombies, and just all over Texas. And the reason they were able to do this is nobody had changed the default password in all of the
It comes
signs.
in the download that you get from the internet. It's the same installation manual, but they don't bother to change what was written on the page, so I don't even have to look.
There you go. So there's my closing one.